1930s, Detroit operated under a strict, unyielding dogma. Luxury cars needed a massive vertical radiator and a heavy rear-wheel drive layout, but pushing power down a long drive shaft forced bodies skyward, creating a top-heavy stance and a space-robbing floor hump. Traditional automakers were completely handcuffed by their own blueprints until an independent underdog flipped the entire drivetrain layout on its head. When the corporate giants of Detroit sat down to design their flagship vehicles, performance was measured entirely by brute force and massive iron block engines. The prevailing corporate wisdom stated that if you wanted a car to ride comfortably and travel fast across the expanding American highway system, you needed a long, heavy hood acting as a physical battering ram against the atmosphere, forcing the air around flat, vertical windshields that behaved like literal brick walls against the wind. Mechanics and engineers operating within this system completely dismissed the laws of fluid dynamics and aerodynamic efficiency, believing that raw horsepower could simply overcome any resistance the atmosphere could throw at them. Vehicles of this era were massive, ostentatious, and mechanically primitive, handling corners with a frightening amount of body roll, wallowing like ocean liners whenever they encountered an unexpected bend at high speed. But in late 1935 at the New York Auto Show, an independent automotive company from Auburn, Indiana, pulled the silk sheet off a machine that made every conventional V8 sedan on Earth look like an archaic relic from a forgotten century. It did not possess a vertical radiator shell, it had no external running boards, and its headlights were entirely invisible, hidden cleanly inside the voluptuous curves of its front fenders. This was the Cord 810, a car so profoundly futuristic that eager spectators at the auto show literally stood on top of the bumpers of adjacent vehicles just to catch a glimpse of its low, sleek, horizontal silhouette. Because of its flat, wraparound horizontal louvers and blunt, squared-off front hood design, the public immediately christened it the Coffin-Nose Cord, a nickname that would forever be etched into the annals of mechanical history. Rival automotive executives and traditional engineers from Detroit openly mocked the radical styling on the showroom floor, confidently predicting that such a bizarre departure from conventional automotive architecture would end in a catastrophic commercial disaster. They assumed that without a massive vertical chrome grille to signal wealth and prestige, the American public would reject the vehicle outright as a weird, unmarketable novelty. Yet, the moment professional test drivers and early owners took the Cord 810 out onto the winding, technical roads of rural America, the corporate mockery stopped completely. Despite carrying the physical footprint of a large, luxurious 5-passenger sedan, this independent underdog handled corners with a flat, stable precision that left contemporary rear-wheel drive luxury cruisers spinning their tires and sliding helplessly toward the ditches, proving that its design was not a superficial styling exercise, but a masterstroke of advanced vehicle dynamics. The secret behind this handling miracle was a brilliant, counterintuitive piece of engineering packaging conceptualized by a legendary design team consisting of stylist Gordon Buehrig and master mechanical engineer Harry Arminius Miller. Instead of copying the established Detroit blueprint, they decided to completely flip the traditional American drivetrain layout on its head, bypassing decades of automotive habit to build a vehicle around a highly experimental front-wheel drive system. To make this radical layout function reliably within the tight confines of a low-slung automobile, they executed a mechanical metamorphosis beneath the sheet metal that challenged the very laws of physics as they were understood in the 1930s, turning their packaging constraints into an overwhelming performance advantage. To fully comprehend the genius of the Coffin-Nose trick, one must look at exactly how Buehrig and Miller packaged the mechanical components under that low, blunt hood. In a standard 1936 automobile, the engine was placed directly over or behind the front axle line, sending its rotational energy backward into a bulky transmission that sat directly beneath the dashboard, which then spun a massive drive shaft to turn the rear wheels. The engineers at Cord realized that if they eliminated the rear drive shaft and differential entirely, they could achieve a level of packaging efficiency never before seen in an American production car. They sourced a potent, all-aluminum 289 cubic-inch V8 engine from the Lycoming Aircraft Engine Company and did something truly insane. They mounted it longitudinally, but completely reversed, turning the engine so that the flywheel faced toward the very front bumper of the car rather than the passenger cabin. By reversing the engine layout, the engineers were able to bolt a highly compact, unified transaxle assembly directly to the front of the V8 block, housing both the 4-speed manual gearbox and the differential ring gear into a single cohesive casting that sat directly over and slightly ahead of the front axle line. This packaging inversion completely freed the rest of the car's architecture from mechanical interference, allowing Gordon Buehrig to drop the entire passenger floorboard down between the massive frame rails, close to the actual pavement. The Cord 810 sat nearly a full foot lower than contemporary Ford, Chevrolet, or Cadillac models, allowing passengers to step directly into the cabin without needing external running boards, a design feature that drastically reduced the vehicle's overall frontal area and lowered its center of mass. This packaging triumph had an immediate, transformative effect on the car's aerodynamic profile, as the absence of a high-mounted engine and transmission linkage allowed the designers to sculpt an incredibly clean, slippery front end. Because the compact transaxle sat low and far forward, the traditional high-mounted vertical radiator was rendered completely obsolete, forcing the team to position a smaller radiator core down low, where it received cooling air through 3 distinctive tiers of horizontal, wrap-around aluminum louvers. This functional design choice allowed the Coffin-Nose cord to slice through atmospheric resistance with a fraction of the energy required by its competitors, meaning that while traditional V8 sedans were screaming at high RPMs just to fight the wind at 70 miles per hour, the aerodynamic cord drifted along effortlessly, maintaining high cruising velocities with remarkable mechanical serenity. When it came to navigating a technical, twisting stretch of road, this radical weight distribution and low center of gravity completely altered the physics of vehicle handling. When a traditional, top-heavy 1936 sedan entered a sharp corner at high speed, its high center of mass caused the entire body to roll violently to the outside of the turn, compressing the primitive leaf spring suspension until the chassis hit the rubber bump stops. This sudden, violent weight transfer lifted significant load off the inside tires, causing the front end to plow straight ahead in a state of terminal understeer, or forcing the heavy rear end to swing out into an uncontrollable slide as the rear tires lost traction. The driver was forced to wrestle with a heavy, unassisted steering wheel, constantly fighting the car's natural desire to roll over or spin out. The Cord 810 responded to the exact same cornering forces in a completely opposite manner, remaining completely flat and stable through the apex of the bend because its center of gravity was positioned so close to the road surface. Because the heavy Lycoming V8 engine and the cast-iron transaxle unit were hanging directly over the front drive wheels, the immense physical mass of the powertrain acted as a natural mechanical press, forcing the tires deep into the asphalt to maximize their mechanical contact patch. Instead of pushing a heavy, resistant chassis from behind like a conventional car, the Cord actively pulled its entire mass through the corner, using the tractive force of the front wheels to stabilize the car's trajectory, meaning that if the front tires did begin to lose grip on a loose or slippery surface, the drivers simply had to keep their foot firmly planted on the accelerator pedal, allowing the front wheel torque to pull the nose of the car back into line. However, moving the entire transmission and differential assembly to the very front bumper of the vehicle created a logistical nightmare that almost broke the engineering team during development, because the gearbox was located several feet ahead of the passenger compartment, separated from the cabin by the entire length of the V8 engine block. Using a conventional floor-mounted gear shift lever was physically impossible. Running a long, convoluted mechanical steel linkage from the driver's hand up over the cylinder heads and down into the front nose cone would introduce an unacceptable amount of mechanical play, flexing, and binding, making gear selection an incredibly sloppy, imprecise guessing game that would easily ruin the premium driving experience expected of a high-end luxury vehicle. To solve this severe packaging constraint, the engineers bypassed traditional mechanical linkages entirely, looking instead to the world of advanced aviation technology to implement an incredibly sophisticated, futuristic solution known as the Bendix Vacuum Electric Pre-Selector Transmission. Instead of a giant, cumbersome iron lever protruding from the floorboards, the driver operated a tiny, beautifully crafted metallic gate shifter mounted on a small pod directly to the right of the steering column. This miniature selector looked and felt exactly like a high-quality throttle quadrant found inside the cockpit of a commercial aircraft, allowing the driver to select their desired gear with the simple flick of a single finger without ever taking their hands off the rim of the steering wheel. The mechanical brilliance of this pre-selector system lay in its unique ability to split the driver's intent from the actual physical execution of the gear change, creating a highly effective mechanical loophole that thoroughly bewildered traditional drivers. While accelerating down a straightaway in third gear, the driver could move the tiny finger lever into the fourth gear slot on the steering column gate at any time, Yet nothing would happen immediately within the drivetrain, as the transmission remained securely locked in third gear while the driver kept their foot on the gas pedal. Moving the miniature lever simply closed a specific electrical circuit, sending a low-voltage signal down a wiring harness to a complex block of electric solenoids mounted directly on top of the distant front transaxle casing. The actual, physical shift was executed entirely by atmospheric pressure, the precise moment the driver fully depressed the clutch pedal to the floorboards. Dropping the clutch opened a mechanical vacuum valve that tapped directly into the intense negative pressure of the engine's intake manifold, channeling that vacuum force into a set of powerful pneumatic actuators that instantly moved the internal shift forks, cleanly sliding the synchronization rings into fourth gear in a fraction of a second. This meant that the intense physical labor of shifting heavy gears across a long distance was handled completely by engine vacuum and electrical currents, allowing the driver to pre-select their gears well in advance of a difficult corner and execute the shift with perfect timing by simply stomping the clutch pedal at the exact millisecond they hit the apex. This advanced powertrain was supported by a highly progressive chassis architecture that drew inspiration from European racing designs, utilizing an independent front suspension system that allowed each front wheel to react to road imperfections completely independently of the other. While traditional American cars utilized a primitive, solid front beam axle that transferred every bump and pothole directly across the chassis, disrupting the steering geometry and causing the front tires to hop violently off the road, the Cord used a sophisticated trailing arm layout paired with transverse leaf springs. This independent movement ensured that the front drive wheels remained in constant, unyielding contact with the pavement, allowing the front-wheel drive system to continuously pull the car forward with maximum efficiency, even when traversing deeply rutted, unpaved rural roads. Despite its towering engineering achievements and its undeniable status as a mechanical masterpiece that was at least 30 years ahead of its time, the tragic reality of the Cord 810-812 was that its revolutionary complexity ultimately caused its premature demise. The independent company simply did not possess the massive financial reserves or the highly specialized manufacturing infrastructure required to mass-produce such an intricate, tightly packaged machine with consistent quality control. When production began in early 1936, the advanced constant velocity joints required to transfer smooth power to the steering front wheels suffered from frequent structural failures, while the highly experimental vacuum electric shifting system was plagued by microscopic vacuum leaks that caused the transmission to unexpectedly slip out of gear or lock itself between ratios during public demonstrations. These severe teething problems led to massive production bottlenecks at the Indiana factory, forcing the company to miss its promised delivery dates for thousands of wealthy buyers who had enthusiastically placed deposits at the initial auto shows. Rumors of mechanical unreliability spread quickly through the automotive community, causing anxious customers to cancel their orders in droves and return to the safe, boring predictability of traditional rear-wheel drive luxury cars built by Cadillac and Packard. By the time the upgraded supercharged Cord 812 model was introduced in 1937 in a desperate bid to save the brand, the financial damage was already done, and the visionary corporate empire collapsed into bankruptcy, bringing a sudden, heartbreaking end to one of the most brilliant chapters in industrial design. Ultimately, the Coffin-Nose Cord rewrote the rules of automotive dynamics. By flipping the traditional drivetrain on its head, this independent Midwestern underdog proved that clever mechanical packaging and a low center of gravity could easily humiliate Detroit's top-heavy giants. Decades before front-wheel drive, independent suspension, and aerodynamic silhouettes became industry requirements, the brilliant Cord 8.0 proved that engineering intelligence will always outhandle raw, unoptimized brute force.